rule for y equals x? Someone different. They switch places. Good. Now, the last rule that we did not discuss yesterday was the y equals negative x, which that's probably the ones on your homework that you were confused on, because I looked at it and I was like, oh, yeah, they threw those in there at you. Now, remember how I said yesterday that we would put a pin in the alternate names for rotations? Well, I remember now what it is, okay? So, if you look on the previous pages where we start with our notes, so I'm at the bottom of page, I think this is 9. All right. So when we reflect over, or I'm at the middle. So when we reflect over the x-axis, another way we write it, this is called error notation. So some other ways that you'll see it is a little r, and then in the subscript, you'll see an x. All that means is little r means reflection, and then the x in the subscript means that you're reflecting over the x-axis. You'll either say x or it will flat out say x-axis. All right. So say that or r x-axis. I've seen it both ways. Sometimes they spell out the word axis. A lot of times they don't. So when you reflect over y, similar thing, lowercase r with a y in the subscript, or you'll see lowercase r and then the whole spelling out of y-axis. All right. Then when we're talking about the y equals x1, the alternate notation that you'll see is the little r and then y equals x. Like they'll actually flat out say y equals x.
Good morning.
Yeah.
Just a quick announcement. We are releasing the
It's not like done yet. So that's on example 3. It was the last one we did yesterday. All right, so is there any questions on just how the alternate notation? Now, one more thing I would like to note is for translations. You already know one of the alternate notations is just the vector form. All right. So if you see brackets like this and then something like that, all this means is this is what you're shifting for the x values. That's the horizontal shift. This is what you're shifting for the y values. So that's the vertical shift. So in other words, you would go right 3 and then down 1. All right. Another way that you would see it is you would have a big T and then the same thing, little vector and then that. All right, so I would make note of that because you may see that as well. So you want to do that in your translation notes, that's where I would make note of that. But more often than not, you'll see it as the mapping version. So XY maps onto X plus or minus blah, 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 Y plus or minus blah, blah, blah. All right. Typically, you'll just see it as the mapping version, which you're the most familiar with. But just in case you do see these two versions, just letting you know. Now, I want to pick up here. So at example 3, this is on page 10, I believe. So we already know what the points are of the rule, but I actually want to show where it comes from now. So,
At this time, teachers please release the seniors to go to the auditorium. All seniors report to the auditorium. Thank you.
so I'm going to graph A, B, and C real quick. So 0, -5. It's A, B, -2, -3. And then C is 2, -3. All right. Now, I kind of discussed this yesterday, but I want to go into a bit more detail. So typically, if you have to reflect over y equals x or even y equals -x, you typically want to essentially find the slope and then find the reciprocal slopes, all right, of the image points. So you would use slope. So basically, it's almost like you're counting from how far away it is from the line and use reciprocal slope to find the image points. So if I graph our new image, because we already know the rule, this would be A prime, -3, 2, B prime, C prime. All right. Oh, whoops. All right. Now, if we know the slope, so for example, if we look between from B to A, it's down 2 over 2. All right. So that means A to B also has to be down 2 over 2. If you look from B to C, there is no slope. It's a horizontal line, which means B to C has to be vertical. And then from A to C, it has to be down 2 over 2. So down 2 over 2. But another way you can look at it is with how far away it is from the next point on the line. All right. So, for example, because remember, it's equidistant from the line of reflection. So, the way I typically do it is I just look at how far away it is from that actual line of reflection. Now, I didn't draw the line to scale exactly, but for example, if we look at letter A, let's say I'm trying to go from, we're good. They must have the bells on the regular schedule. Yeah, we're still here till 10, guys. We're good. Okay, so what happens is that you want to count essentially how far away it is from some point on the line. So I'm going to say from here. All right, you just pick a spot on the y equals x line and use that as kind of a reference point for your slopes. Okay, so from A, if I did my rise over run, I would do up 1, 2, 3, and then over 1, 2. All right. So for A to my random point, that slope is 3 over 2. So what that does is that it shows you, if you had to do it by hand, how to find it. Because what happens is A prime should be its reciprocal. So it should be up 2 over 3, which if we use that same reference guide, if we go up 1, 2 over 1, 2, 3, we're at point A. So as long as you pick a point on the actual line y equals x and find slopes based off of that reference point, it makes it a little bit easier. Now, why am I going into this? Because you'll do the same thing for y equals negative x. So let's look at example 4. All right. So we're going to plot these points, which I think they're the exact same points from the previous. So take a minute, plot those points real quick. So 0, -5. -2. Now, we're going to reflect this over the line y equals negative x. So instead of it looking like this, it's going like this. All right, it's essentially the same line. It's just going the opposite direction. Prime. So here's our new triangle. And then I'm going to try and draw this line as accurate as possible. The easiest way to do it is it's a 1 by 1. All right, so up 1 over 1, up 1 over 1. So it's really just cutting directly through diagonally the squares. So if you start the origin and you start there, you can make the diagonal from there. Now, I'm not going to tell you the rule for this one just yet. We're going to find it out using that slope method. All right. So we are going to use that slope method that we just did. So we're going to find a slope and then the reciprocal slope to find the image points. So like I said, just pick a reference point on the line. So I'm going to pick, let's just go with the origin. That's always a good one. All right. So let's just go with the origin as our reference point. All right. We have to figure out the slope, that what it takes from each point. And then we do the reciprocal for our new image. All right. So let's start with A because that's the easiest one. So if we start with A, we're doing our slopes. So slopes from origin. All right, and remember, that's rise over run. So if I'm going from A to the origin, I'm going to go up 1, 2, 3, 4, 5, and there's no run. So technically, we would say it's an undefined slope, but because we want a reciprocal, we're just going to say that the rise is 5, but there's no run, so 0. Yeah, so guys, they have the bell schedule on the actual schedule of what a normal school day is. So by this time, second period just started. All right. If you guys didn't have homeroom. So that's a them issue. So that means if I had the reciprocal slope, this would make my A prime. So what would the reciprocal slope be? So 5 over 0 is our original slope. So what's the reciprocal slope? First off, what does it mean? 0 over 5. So remember, reciprocal just means flip them. All right. So that means we're not going up any from the origin, but we are going over 5. So 1, 2, 3, 4, 5. So right here. So this would be our A prime. So A prime would be at what point? 5, 0. All right, so that's our first point. Now let's do B together. So I'm finding B, the slope of B from the origin as the reference. So from B, I'm going to go up 1, 2, 3, and then to the right 1, 2. So that means we have a rise of 3 and a run of 2. So if I take the reciprocal, what would be the slope of B prime? 2, 3. So if I go from the origin, that'll be my starting point now. I'm going to go up 1, 2 over 1, 2, 3. So this will be B prime. And what is that point? 3, 2. Good. Now, try C on your own. Take a minute, try C on your own. Now, pay attention to the direction you're doing your rises and your runs, all right? So, for example, if your run is going to the left, it'll probably be what? Negative. So, if you have a negative in the rise, are you going up or down? Down. So guys, this is just to show you where the rules come from and how you would do it if you had to like just do the equidistant thing. But if you remember the rules for y equals x and y equals negative x, that's all that matters. All right. So if you're a bit confused with this process, that's okay. You just got to remember the rule. I just want to make sure that you guys at least have some sense of understanding of where the rule comes from. Right, thumbs up, ready. All right. Can someone tell me what slope they got for C from the origin? Sutton. 3, -2. Good. So you went up 3 and then to the left 2. So what would the slope be for C prime? Someone different. And -2, 3. So that means you would go to down 2 and then to the right 3. All right. So what was the final point at? Someone different. Audrey. 3, -2. Good. That's exactly what I got. Now, look at our old points versus our new points. What do you think the rule is when we reflect over the line y equals x? So if we start with xy, what do you think happened? So they got converted to yx, so they switched, But that's not all that happened. Something else happened. Their sign switched. So the only difference between y equals x and y equals negative x is that they both switch the places of the points. All right. So x and y switch their places. So the y value is now in the x value, and the x value is now in the y place. All right. But with y equals negative x, they also switch their signs. All right. That's the only difference. And you can remember that by going, okay, if it's y equals negative x, but if y is negative x, all right, that just means that we also got to flip the signs as besides flipping the point values. I'm sorry, I'm kind of a mush mouth today, guys. It's been a long week. All right, any questions on that? All right, so with line reflections, so this is when you're just reflecting over any particular line. So when a point A is reflected across line M, so just any line, we find that its image point by the following. So first off, its A does not lie on the line M. Then to locate A prime, we have to note that line M should be perpendicular from A to A prime. And the distance from A to B is the same as from A prime to B. Meaning, if we look at this lovely picture over here, if this is our line of reflection, and this is where A is, A prime should be, if we drew a segment between A and A prime, it should create a right angle over our line of reflection. It should also create two congruent segments if we were to draw a point where both lines intersect. All right. Now, this is just basically saying that that's where this rule comes from both these two rules. So it's something just interesting to know, but really in reality, as long as you know the rules, you're okay. All right. So with the guided practice, if we're reflecting over, let's just do this very quickly. If we're reflecting over the line y equals x, so that means our rule is what? So if we start with xy, we're mapping it to what? When y equals x.
Or what?
Yx, yeah. The negative y negative x is y equals negative x. So, what will my new points be here? 4, -3. What about here? -19, -7. Then here. -6, +12. Now, when y equals negative x, that means that if we start with xy, like Ann Bradley said, we'll get negative y, negative x once we reflect it. So, what will my new point be for number 1? 4, 7. What would it be for number 2? 3, -6. And then for 4, or not 4, for 3, -11, 4. All right. Now, these are some questions that you may want to ask yourself. All right. So, what the slope of the line of reflection is, depending, it should be either 1 or -1. Because, y equals x, that's clearly a slope of 1. Y equals negative x, that's a slope of -1. So as long as there's a general slope of 1, whether it's the positive or negative version, it's fairly easy. Now, what is the slope of the line segment formed between the pre-image and the image point? So basically, let's, for example, look at the one we just did up here. If I did from, let's say, A to A prime, all right? If I counted this, it would be up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. So this line right here, what's its slope? So if it's 5 over 5, what's the slope? 1. All right. Let's check for B. And you guys don't need to write this down. I'm just kind of drawing over it. But if I check B, we go up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. What's the slope? If it's 1. C, we go up 1, 2 over, or up 1 over 1. So the slope is. So whenever you reflect over these lines, it will either become 1, or if we look at our previous one, we go from B to B prime, up 1 over 1 to the left. That means the slope is -1. So in other words, the slope is the opposite of the one that we started with. That's why we use reciprocal slopes to find that. Does that make sense? All right. So that means that it would be either 1 or -1. So it means you find the slope from the pre-image to a point on line of reflection. Then use the reciprocal slope to find, use a reciprocal slope from that same point on the line of reflection to find the image point. All right. That, or you just take the opposite slope. You need to make it so that it has a slope of 1 or -1, depending on which line you use, from one point to the other. All right. I still think the reciprocal method is a little bit more friendly. But again, if you remember the rule, you don't even have to worry about that. All right. Any questions on reflections? I know that was a lot and a lot of word vomit on my part. Apologies for that. All right. So that being said, I had questions on specifically 6 and 8 on your homework. So I'm going to go over number 6. Now, this is one of those where it may have been the line y equals x or y equals -x that it reflected over. How do I know? It doesn't look like it's flipping over either axis, meaning it doesn't look like it's going from like just a flat out horizontal or vertical flip. It looks like it twisted. It almost looks like a rotation. All right, so if it almost looks like a rotation, but it's asking you to find a reflection, it's probably either y equals x or y equals negative x. Now, how can I determine which one? You want to take the slope between the 2 points. So the pre-image point to its image point. If it is a positive, that means that you're reflecting. So if you get a positive one, that means you're reflecting to it's actually y equals negative x. So if you get a positive slope, it's going from, Lord, I'm confusing myself. Yeah, so if you get a positive slope, that means you are going from y equals negative x. If you get a negative slope, you're going from y equals x. So in other words, if you get a slope of 1, that means it's y equals negative x because we're talking about the opposite slopes. All right. So if you get a slope of -1, it's y equals x. And that's if you go from pre-image to the image. All right. And I would do more than 1 point to check yourself. So I'm going to start with x. So if I start with x here, I'm going to go up 1, 2, over 1, 2. So 2 over 2 is, what is that slope? 1. All right, so I'm thinking it might be reflecting over the line y equals x, but I'm going to do another one to check. All right, don't always go off the first one, always do at least 2. So I'm going to do from y. So I'm going to go to the left one and then down 1. So -1 over -1, what's the slope? 1. So I'm assuming that I'm reflecting over the line y equals negative x. So if I draw that line, it'll look like this. And just knowing what we know about the reflection, it's pretty feasible that that is the correct line, because if you look, the y's are on the opposite sides of each other, the x's are on the opposite sides of each other on the line. That's a good way to check yourself. If they're on the same side of the line, so for example, if I drew the y equals x line, so let's say I drew the y equals x line. That's an ugly line. But if you're reflecting over a line, does that mean that the image and the pre-image points should be on opposite sides of the line? Yeah. Well, these are both on the same side. So it can't be y equals x just by process of elimination. All right. If you looked at the y-axis, the y's are on the same side of the line. X-axis, the w's are on the same side of the line. All right. So that's another way you could go about it, like for the process of elimination. All right. Does that make any sense, or am I just going left? Yeah, that's what I thought. Okay. Yeah, and we'll do more practice with this. All right. So if we were to write a rule for this using our notation, so xy, that means, what's the rule for when y is equal to negative x? Negative y, negative x. And again, guys, if you just know the rule, it'll save your life. That's really all you need. Okay. So another way you could have done this is if you looked at the points. So for example, the y's. Point y is at the point -1, 2, whereas y is at the point -2, 1. All right. They switched places and then they became the opposite signs. So it has to be y equals negative x because that's the only rule that fits that case. Okay. Yeah, I'm sorry with the whole slope thing. Just go off the rule, guys. Just go off the rule. It'll make your life so much easier. Just memorize the rule. All right. Okay, does that kind of clear up any questions you may have had on the homework from yesterday? Does anyone have any other questions on the homework from yesterday? Yeah. Okay, 7. All right, this might be... Okay, so this one's actually a multiple transformation. 2 reflections happen. All right. So if we start with our pre-image, or no? Okay, first off, let's just start by listing the points. So when in doubt, just start by listing those points. Okay. So K is at the point -1, -4. L is at the point -1, -3. And M is at the point -4, -4. Now we're going to list the points for the primes. So K prime is 1, 4. L prime is 1, 3. And then M prime is 4, 4. Now, does that, going from those points, does that fit any specific rule that we have? No. So if that's the case, that means that 2 transformations happened. All right. So in this case, the way I'm looking at it, it looks like we would reflect over the y-axis first and then reflect over the x-axis. That's what it looks like to me. So sometimes they may throw a mixed one at you because it does say mix, like write a rule for each transformation. That could have also just been a rotation. I think that one may have been a typo because you haven't learned rotation yet. And that, like at first glance, that looks like a rotation to me. All right. So, yeah, you guys know what? Disregard 7 and 8. Because I think those are rotations. When we made this packet, I think those got slipped in and you guys haven't learned rotations yet. Okay, so just disregard those. So essentially, if you did 3 through 6, I'll give you credit. And also 5 is a translation if you didn't realize that. So if it just says write a rule for each transformation, all right, that means that they're throwing in something extra at you. All right. Okay, so again, I'll check that homework tomorrow. But an additional homework assignment for tonight, because I know most of you already did the homework assignment besides the ones that you didn't do. But do the next page 13. This is... So do all of page 13. It's just a review from Math 1 over graphing lines, and that's pretty much it. So does anyone need to see a quick example of that just for review's sake? Okay. So I'm going to do number 12. All right. So let's do number 12 together real quick because we got about 10 minutes left. All right. So remember, when we're talking about slope-intercept form. It's in the form y equals mx plus b, where m is what? Slope. And b is the what? Y-intercept. So my personal preference, I usually start by graphing the y-intercept. So where would my y-intercept be for this line? At 1. So at the point 0, 1, this is my y-intercept. Now remember, slope is typically in the form rise over run. So if you just see a whole number, just put that number over 1, that's your run, okay? So like if it's a slope of 3, 3 over 1. But we're going up 2 over 3, and it's a positive slope, so we know we want our line to look something like that. So I'm going to go up 1, 2 over 1, 2, 3. And I'm just going to keep doing it until I got enough to kind of fill out a line. So it would look like that. And that's really all you got to do. It's just a review from Math 1. All right, any questions on that? All right, so we got about 10 minutes left of class. So if you want to work through that homework for like a couple minutes, and then you can pack up around when there's about 5 minutes left, that's fine. Also, guys, tomorrow, so first thing tomorrow, we're going to have a very short quiz just on the stuff that we've learned so far. So translations and reflections. All right. It's like partially multiple choice, partially short answer. I think it's only like 6 questions. All right. So just be prepared for that first thing tomorrow.